Okay guys, we are still dealing with the same exam paper. You can see it is still May-June 2025. It is paper 1, right? Paper 1 multiple choice. We've worked out questions 1 through 10 and we're about to proceed. So let's get it done. So let's do question 11. Let's maybe do from 11 to 15. We're going to see. We don't want the video to be too long. So question 11 reads, which description of globular proteins is correct? They are only found in cell surface membranes. That's not correct. Hemoglobin is a transport protein that is used to transport oxygen to the cells. It is a protein that is related to red blood cells. That's why you find hemoglobin, right? And it transports oxygen. It makes it possible. Oxygen is not transported without the aid of red blood cells, and red blood cells don't function alone. They require the presence of hemoglobin. Hemoglobin is the one that is going to transport oxygen, right? It forms oxyhemoglobin, so that's how they join together, and then that's how oxygen is delivered to all tissues and cells. So A is wrong, and I've got B. They only contain amino acids with hydrophilic R groups. That's not correct. They also have hydrophobic R groups, for sure. Okay. C. They can change shape by using energy from ATP. That's right. And D. They always have a quaternary structure. That's wrong. I've got myoglobin. It does not have a quaternary structure. It has got a tertiary structure. So the correct answer here is C. All right, let's proceed. You want to do question 12 now. Question 12 reads, which diagram shows where hydrogen bond occurs between two water molecules? So we've got option A, right? So option A is the correct answer here because you can see that hydrogen bonds is formed between hydrogen and oxygen. That's because hydrogen and oxygen have got different electronegativity values. Okay, what we mean is that oxygen is more electronegative than hydrogen. Therefore, as they actually share electrons, the one that is more electronegative is going to pull electrons towards its direction, closer to itself. In this case, oxygen is more electronegative than hydrogen. It's going to pull electrons closer to itself. So it's going to have a partial negative charge, okay, represented by this delta minus, right? And in this case, hydrogen, which is less electronegative, is going to have a partial positive charge. That's how it enables the formation of hydrogen bonds. So it cannot happen like this. For example, here it's wrong, and this is why it's wrong is that they're assuming that hydrogen bonds is formed between hydrogen and hydrogen atoms. That's not true. C is wrong because here it says that both hydrogen atoms here have negative charges or partial negative charges. That's wrong, okay, because that would mean that hydrogen is more electronegative than oxygen, which is not true. and we have D here, also wrong. Okay, it's also wrong basically. You get the idea, because here they're saying that oxygen has got a partial positive charge, which is wrong, right? Okay, let's do number 13. All right, number 13 reads, some detergents disrupt hydrogen bonds between water molecules. Which row shows the correct effects of detergent on the specific heat capacity and latent heat of vaporization of water? So you have to understand what specific heat is. Okay, specific heat capacity of a substance has to do with uh, the amount of energy required to raise a substance by 1 degree Celsius, to raise the temperature of a substance by 1 degree Celsius. All right, the amount of heat, amount of energy per unit of mass that is required to raise the temperature of a substance by 1 degree Celsius or even Kelvin. That's what specific heat is. All right, so specific heat has to do with change in temperature, and latent heat of vaporization has to do with state of a substance. Okay, the amount of energy required to change the state of a substance from liquid to gas at a specific temperature, at a constant temperature. Most of the time it's going to be at the boiling point. Okay, for example, water, okay, it's going to change from liquid to gas when it is boiling. Okay, so that's the temperature at which the change takes place. Boiling point, 100 degrees Celsius for water, for example. Now let's read the question again. The question is, some detergents disrupt hydrogen bonds between water molecules. Which row shows the correct effects of detergents on the specific heat capacity and latent heat of vaporization of water? Specific heat, in this case, if you disrupt the hydrogen bonds, if you decrease the amount of hydrogen bonds, you disrupt them, what you are doing, you are decreasing their specific heat capacity, okay, and you're also decreasing their latent heat of vaporization. Okay, so by doing that, you make it easy to change the temperature of water. For example, by just applying or allowing it to absorb a small amount of energy or less amount of energy. So yeah, that means that the specific heat capacity of water would decrease. Okay, and latent heat of vaporization would also mean that you need now less energy to allow water to change from liquid to gas. So the answer here is decrease, 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 decrease. All right. All right. So then we've got this question here. 14. An investigation was carried out to see if compound X could improve the thermostability of an enzyme. Thermostable enzymes will function well at high temperatures. The results of the investigation are shown. So you've got on the y-axis, okay, so this is the dependent variable enzyme activity, and so on this, and we've got on this axis here the vertical one, enzyme activity. So this is actually the dependent variable, and here you've got on the horizontal axis temperature, which is the independent variable. Right now you've got the graph here. Experiment 1 with compound X here, and then experiment 2 without compound X here. All right. Now let's analyze the options. Which row is correct? Compound X makes the enzyme more thermostable. Let's see. Okay, they're saying that uh, uh, thermostability means that, well, in this case, they say here that thermostable enzymes will function well at high temperature. We can see that when you add compound X in experiment 1, the ability to function well at high temperature decreases. So compound X makes the enzyme more thermostable. The answer is no. So no. So it can't be A and B. Okay. Now, at 40 degrees Celsius in experiment 1, most of the enzyme active sites will no longer be complementary to the substrate. This is true. Okay, this is true. Here you can see here. You can see here that the enzyme is now denatured. Right, it's no longer complementary. The shape of the active site has been changed. So it is true. Now the last one here. At 45 degrees Celsius in experiment 2, approximately half of the enzymes are forming enzyme substrate complexes. Okay, so enzyme substrate complexes. Okay, so is it true? At 45 in the experiment 2, approximately half, let's see, 45 is here. Okay, so we are here, so it is true. 50%, right? It corresponds to almost 50% here, right? You can just follow this line. You can see that it actually hits here, almost at 50%, which is true. So the answer is C. All right, and then we've got this question here, right? So the table shows the results from an investigation into the effect of temperature on an enzyme catalyzed reaction. All other variables were standardized. So 10, 3, 27, 30, 16, 40, 33, 50, 32, 60. So we see an anomalous value here, right? It's not normal. Okay, we are talking about enzymes here, and by this time something should happen here. They've got almost the same value as not normal. In this case, we are talking about the rate of reaction. All right, so let's see the options. What is the correct conclusion? 40 degrees Celsius was the optimum temperature. It's not supported by the table. The results in the table doesn't support that, or the results in the table don't support that conclusion. B, the data for 50 degrees was anomalous. That cannot be a conclusion. We're not studying about anomalous data here, so it doesn't make sense. So C, the optimal temperature was between 30 degrees Celsius and 50 degrees Celsius. And then D, all the enzymes denatured at 60 degrees. Oh no, it's not true. We still have a rate of reaction taking place here. It's not 0, it's 14, so D is not true. So the most correct answer here is C. Okay guys, thank you so much for watching this video.